Now let us discuss the chapter fractions, decimals and rational numbers. Now we come across many situations from our day-to-day life where we can use the fractions, and in your earlier classes we have learnt how to represent the proper fraction, improper fraction and mixed fraction, and we have also learnt the addition and subtraction of the fractions. Now in this class we will revise all those topics once again, and we will also learn how to multiply and how to divide the fractions, and we will also learn the multiplication and division of decimal numbers, and also the bigger collection of numbers, that is the rational numbers. So we will find the equivalent rational numbers, and we will also learn how to add and subtract the rational numbers. Now first, what is a proper fraction? A proper fraction is a fraction that represents the part of the whole. For example, if you take a circle, now in this half the circle is shaded. Now out of two equal parts, one part is shaded, so this can be represented by 1 by 2. Now for example, there is a square. A square has been divided into three equal parts. So out of these three equal parts, one part is shaded. Now this equals to 1/3, 1 by 3. So this is a proper fraction, and here 1 by 2 is also a proper fraction. So proper fraction means it is a fraction that represents the part of the whole. So here the half, and this is 1/3. Now what is improper fraction? Now what is improper fraction? So improper fraction means if the numerator is greater than or equals to denominator, then the fraction is said to be improper fraction. For example, 5 by 3 or 7 by 4 or 11 by 5. So in all these fractions, the numerator is greater than or equal to the denominator. So then these fractions are said to be improper fraction. Now what is a mixed fraction? Now every improper fraction can be written in the form of mixed fraction. Now first let us see what is a mixed fraction. A mixed fraction contains an integral part plus fractional part. And this fractional part must be a proper fraction. For example, if you take the improper fraction 5 by 3, and if you divide 5 by 3, then we get 3 ones are 3, then 2 is the remainder. This can be written as 2 by 3. So this 5 by 3 equals to 1, 2 by 3. So this improper fraction can also be written in the form of mixed fraction. In this mixed fraction here, 1 is the integral part and 2 by 3 is the fractional part. And this fractional part 2 by 3 is a proper fraction. Now if you take another improper fraction 7 by 4, so this 7 by 4 equals to, if you divide 7 by 4, 4 ones are 4, and 7 minus 4, 3 remainder, 3 by 4. So this equals to 1, 3 by 4. So this improper fraction 7 by 4 can be written in the form of mixed fraction as 1, 3 by 4. So here also 1 is the integral part and 3 by 4 is the fractional part. Now let us see what are the like fractions and what are unlike fractions. Now the fractions with equal denominators are said to be like fractions. And for example, 7 by 3, 5 by 3. So these two are the fractions with equal denominators. So these two are said to be like fractions. And if you take another example, 10 by 13, 7 by 13 and 11 by 13. So these fractions also have the same denominator. So these fractions are also said to be like fractions. And what are unlike fractions? Now the fractions with different denominators. For example, 5 by 8, 3 by 7. So these fractions are the different denominators. So these are said to be unlike fractions. And if you take another example, 10 by 17, 5 by 13. So these fractions are also said to be unlike fractions. So we can add or subtract only the like fractions. The addition and subtraction of like fractions is possible. So if the given fractions are unlike fractions, first you should make them like fractions, then we can do addition or subtraction. Now so far we have discussed what is the proper fraction, what is improper fraction and a mixed fraction, and we have also seen what are the like fractions and what are the unlike fractions. Now we can add or subtract only the like fractions. Now let us see the question. Solve the following. 1 minus 4 by 7. So this 1 can be written as 7 by 7, as the denominator of the second fraction is 7. So we write 1 as 7 by 7 minus 4 by 7. Now these two fractions are like fractions because they have the same denominators. Now when the denominators are equal, then we can add or subtract the numerators. Now 7 minus 4 divided by 7. So this equals to 7 minus 4 is 3 divided by 7, which is a proper fraction. Now the second question, 5 by 8 minus 1 by 6. If you observe these two fractions, they are not like fractions, they are unlike fractions because their denominators are different. So first we should make them like fractions. So we have to make the denominators equal. So for that, let us find the LCM of the denominators. So 8 comma 6 LCM. 2 4s are 8, 2 3s are 6, then 2 2s are 2 3 will not go, then 3 is same. Now LCM, as 2 and 3 are prime numbers, we can stop here itself. Now 2 into 2 into 2 into 3. Now this equals to 2 2 are 4, 4 2 are 8, 8 is 24. Now 5 by 8 into, see the denominator 8, 3 times 24, so we can write 3 by 3 minus 1 by 6 into 6, 4 times 24, so we can write 4 by 4. Now this equals to 5 3s are 15 by 24 minus 1 4s are 4 by 6 4s are 24. Now these two are like fractions. Now we can subtract the numerators. So 15 minus 4 is 11 divided by 24. Now the next question, 2 by 3 plus 3 1 by 2. So here the two fractions are mixed fractions. So first let us convert the mixed fractions into improper fractions. For that we multiply 3 2s are 6 plus add 2, then 3 2s are 6 plus 2 8 by 3 plus 2 3 are 6 plus 1 7 by 2. So here also the two fractions are unlike fractions. So we should make them like fractions. So first find the LCM of 3 and 2. So that is 6. Now 8 by 3 into, so the denominator 3, 2 times 6. So we multiply both numerator and denominator by 2. So 2 by 2 plus 7 by 2 into the denominator 2, 3 times 6. So take 3 by 3. Now this equals to 8 to the 16 by 3 to the 6 plus 7 3 are 21 by 2 3 are 6. Now this equals to, now these two are like fractions, so we can add the numerators. So 16 plus 21 is 37 by 6. Now this is an improper fraction, we can convert into the mixed fraction. 37 by 6, 6 6 are 36, remainder 1, this can be written as 1 by 6. Now this equals to 6 1 by 6. Now the next question, arrange 2 by 5, 1 by 3 and 3 by 10 in ascending order. To arrange the given fractions either in ascending order or in descending order, first they must be the like fractions, means their denominators must be equal. So then we can arrange them either in ascending order or in the descending order. Now if you observe the fractions, their denominators are not equal. So first let us find the LCM of the denominators. So 5, 3, 10. Now we can take two tables. So 5 is not divisible by 2 and 3 is also not divisible by 2, then 2 5s are 10. Then again we can take 5 table, 5 ones are 3 is not divisible and 5 ones are 5. Now LCM of the denominators equals to 2 into 5 into 3. So this equals to 2 5s are 10, 10 3s are 30. Now we will take the fractions 2 by 5 equals to 2 by 5 into, so the denominator 5, 6 times 30, so we multiply both numerator and denominator by 6. Now this equals to 2 6 are 12 by 5 6 are 30. Then let us take the next fraction 1 by 3 equals to 1 by 3 into the denominator 3 10 times 30, so we multiply both numerator and denominator by 10. So 1 tens are 10 by 3 tens are 30. Next, the third fraction 3 by 10. 3 by 10 into the denominator 10 3 times 30. So we multiply both the numerator and denominator by 3. 3 by 3. So this equals to 3 3s are 9 by 10 3s are 30. Now if you observe the fractions, then they have the same denominator, so these are the like fractions. Now we can arrange them in ascending order or in descending order. Now the smallest fraction is 9 by 30. Next largest is 10 by 30. Next largest is 12 by 30. So 9 by 30 means 3 by 10 and 10 by 30 means 1 by 3 and 12 by 30 means 2 by 5. So by making the denominators equal, means by converting the fractions into like fractions, we can arrange the given fractions either in ascending order or in the descending order. Now let us see the next question. A rectangular sheet of paper is 5 2 by 3 centimeters long and 3 1 by 5 centimeters wide. Find its perimeter. So we know that the perimeter of a rectangular sheet is 2 of length plus breadth. Now there is a rectangular sheet whose length is 5 2 by 3 centimeters and breadth 3 1 by 5 centimeters. Now its perimeter of rectangle P equals to 2 of length plus breadth Now this P equals to 2 of length is 5 2 by 3. So if you convert into the improper fraction, 3 5s are 15 plus 2 17 by 3 plus 5 3s are 15 plus 1 16 by 5. Now here also these two fractions are unlike fractions and the LCM of the denominators is 15, so we take 2 of 17 by 3 into 5 by 5 plus 16 by 5 into 3 by 3. And this P equals to 2 of 17 5 are 85 divided by 15 plus 16 3 are 48 by 15. Now here the denominators are equal, so we can add the numerators. 2 of 8 plus 5 13 and 1 plus 4 5 5 plus 8 13, so 133 by 15. Now if you multiply 133 by 2, so we get P equals to 266 by 15, and this P equals to, so if you divide 266 by 15, 15 ones are 15, 6 minus 5 1, 2 minus 1 1, then 6, 15 sevens are 105, and 6 minus 5 1, 1 minus 0 1, so this can be written as 11 by 15. So then perimeter is 17 11 by 15 centimeters. Now the next question, Abdul is preparing for his final exam. He has completed 5 by 12 part of his course content. Find out how much course content is left. So let us consider the total course content is 1. Total course content. From this whole course content, he has completed 5 by 12 part. Then you should find out how much part of the course content is left. So from this whole course content, he has completed 5 by 12 part. Now, part of the course content completed. Part of the course content completed equals to 5 by 12. Now, part of the course content left equals to, from this whole course he has completed 5 by 12, so we write 1 minus 5 by 12. So this 1 can be written as 12 by 12 minus 5 by 12. So this equals to, so now the denominators are equal. If you observe the numerators, 12 minus 5, that is 7 by 12. So he did not complete 7 by 12 part of the whole course content. So the completed course content is 5 by 12, then the course content left is 7 by 12. So if you add again 5 by 12 then 7 and 7 by 12, then you will get the whole course content as 1. Till now we have done how to add and how to subtract the fractions. Now let us see the multiplication and division of fractions. Now first, the multiplication of fractions. Now multiplication of a fraction by a whole number. Now we know that the multiplication is nothing but the repeated addition. For example, if you want to find 5 into 3, so 5 times 3, so we will add 3 5 times So this gives 3 plus 3, 6 plus 3, 9 plus 3, 12 plus 3, 15. And so if you take any fraction 2 into 1 by 2, so here 1 by 2 is added 2 times, so 1 by 2 plus 1 by 2. Or if you take 1/3 3 times, so 3 into 1 by 3, so then this equals to 1 by 3 plus 1 by 3. Now in this case, so when the denominators are equal, so we can add the numerators, then we get 1 plus 1 plus more 1 by 3. Now this equals to, so when the denominators are equal, we can add the numerators, 1 plus 1 2, 2 plus 1 3, 3 by 3. So this equals to 1. And here also we can add the numerators, 1 plus 1 2, 2 by 2 equals to 1. Or you can take 2 into 1 by 4. So this equals to 1 by 4 plus 1 by 4. So this equals to 2 by 4. Now let us see how to multiply a fraction by a whole number using pictures. Now let us take a square. And this square has been divided into 4 equal parts. And we'll take another square of same size which has been divided into 4 equal parts again. Now, in the first square, we will shade one part out of 4 equal parts. So this represents 1 by 4 plus. Now, in the second square, we shade one part out of 4 equal parts vertically. Now, this represents again 1 by 4. And if we combine these two squares with shaded parts, so then we get the square with the 2 shaded parts. Now this equals to 2 by 4. So there are 4 parts out of 4 equal parts, 2 parts have been shaded. Now, so this is the addition. So this 1 by 4 plus 1 by 4 2 times. So 2 into 1 by 4 equals to 2 by 4. So when you multiply a proper fraction by a whole number, so then we multiply the numerator of the proper fraction with the whole number and keeping the denominator same. So even when you take the multiplication of an improper fraction with whole number, so then we will multiply the numerator of the improper fraction with the whole number keeping the denominator same. For example, 3 into 7 by 5. So here 7 by 5 is an improper fraction and 3 is a whole number. So when we multiply an improper fraction with the whole number, so here also we multiply the numerator with the whole number keeping the denominator same. So then 3 into 7 by 5. So this equals to 3 7s are 21 by 5. So when you multiply a proper fraction or an improper fraction with a whole number, so we multiply the numerator of the proper or improper fraction with the whole number keeping the denominator same. Now for example, 6 into 3 by 11. So this equals to, so we will multiply numerator with the whole number 6 into 3 keeping the denominator same 11. So this equals to 6 3s are 18 divided by 11. Now here onwards half represents the multiplication. For example, 1 by 4 of 12 is same as 1 by 4 into 12. So this equals to 1 into 12 by 4. So we can cancel 12 and 4, 4 ones are and 4 3 are 12. So 1 3 are 3 divided by 1 means 3. So here half represents the multiplication. So 1 by 4 of 12 means 1 by 4 into 12. For example, 2 by 5 of 15. So this equals to 2 by 5 into 15. Here 5 ones are and 5 3 are 15. So 2 3 are 6 by 1 equals to 6. So here also half represents the multiplication.